let's take a look at a dictionary in Python. Now, why do we want a dictionary? Number one is it's effectively a key value pair, and it's really easy to look up values based on the keys. As a matter of fact, it often gives O to the 1 performance, which means that no matter how large the hash map is, it takes the same amount of time, or roughly the same amount of time, to access an element and usually insert an element as well. Think about that compared to a traditional list or array, where you don't know where the element is. It might be in position 1, might be in position 100 or position 1000, and the only way to know for sure is to shake hands with every single element and say, okay, are you the element that I'm looking for? But with a dictionary, this is common in most programming languages, and these are often called dictionaries or hash maps or something like that. It actually is able to compute a value based on the key using what's called a hash code or a hashing function. And that value tells us approximately where that key will be in the collection. So you get direct access to that key no matter how big the collection is. So it's a very efficient mechanism for storing and retrieving data, especially if you have a large amount of data. So key value pairs, we'll typically set it up like this. We'll declare a variable, then we'll have the equal sign and then a curly, and then close curly at the bottom. And then inside we'll have a series of name value pairs, the names oftentimes in quotes, and then a colon to separate the name and the value. So these items are ordered and they are changeable, so it means we can change the values inside of here, but we cannot have duplicates. So here's an example that I'm going to set up shortly where I have a dictionary called Redbud, and after that I have a list of attributes for any kind of plant, but in this case I'm giving them values that correspond to Redbud. So genus is Cercis, species Canadensis, common eastern redbud, max height 25, edible is true, and then we simply take a look at the results. Now, if I tried to have edible twice, you notice that edible is only going to be stored once, and as a matter of fact, that last value is the one that's going to be stored. But I can't have two different keys here effectively with the same name, because remember, that key is how we are looking up this individual item. A couple things that we can do. We could refer to an item within the dictionary as we would with the square bracket and the single quote, and then the name of that key inside of the single quotes. We can also get the length or the number of items in this dictionary with the length function. Now here's an interesting thing that we can do is we can actually have a dictionary of lists. And that means the key is a normal key, which is oftentimes a string, but the value is a list or a comma-separated array of values. So if we take a look at this one, we have Redbud and maybe some heights for Redbud, and then Pawpaw and a few different heights for that, and then Apple. And down here we can see we can access the entire collection by saying height and then Redbud inside. And by entire collection I mean this list that's associated with the key Redbud. Or we can access an individual element within the list. So you see here we're pointing to the key called Redbud and then the 0 element within the list that follows. In this case we're doing a type, in this case we're doing a print, but either way you notice that we can either access that list as an entire unit or access an individual element of the list. We just kind of have to walk down there by taking the entire collection, the entire dictionary, and then referring to the one dictionary element, and then the next suffix says, okay, what do we want out of the list that belongs to this key? So that's a look at dictionaries. One handy thing that we'll explore is that once we have a dictionary, it's easy to create a data frame from it.